Okay, so we're talking about how the client and server can talk to each other. So this program, HW6 server.cpp, toward the end of the program, the main function that we have this few line, this three line, in fact, is try to um, set up a server, a HTTP server. We're using the HTTP, the library for C++. And when you've done this, you can see that the first line is essentially set up the port number for me to receive any requests related to HTTP. And then I'm using my HW6 server, this class I created above. This is actually from the JSON RPC program. And then I basically start running the server. And this two line added together, it will set up your server to receive the call for those two remote procedure calls. It will either go to update or go to search. So these two lines are actually set up your program, your server to be receiving. And then when you say start listening, it will start waiting for any request from the client, any client who can contact this port. Okay. Okay. The theory is similar to the regular HTTP browser, HTTP server. So in some sense, your client. Now I'm going to look at the client side.
So do we call search and update from the client's function?
Yes, yes, that's right. So I want to show you an example. This is a HW6 client reducted. Let me show you where I do this, okay? Toward the bottom of the HW6 client, you see that I'm actually also create a client. I have this two line to set up my client. So my client number one is actually set at a port number because I know I'm running the server on the same machine. That's why I'm using localhost. And then colon, the port number I just gave, 8384. So this two number must match. But if you want to run a remote machine, you're running on a different server, you potentially can type the keyword, the IP address, .237.6.102 or whatever IP address is. You can do that as well. And this will give you that IP address. So this program allows two programs to communicate regardless where they are. Okay, as long as you get the port number and the IP address correct, and then you will get to the server. All right, so let me change this back. So localhost is just saying that if this is on the same machine, it's probably easier for testing. Okay, and so we have this two line to set up the client, but now I'm going to tell you how I call so in the redactor, you see I'm actually calling here. I just say my client update. So I'm actually using this to call the server's function update. So it will be invoking the update function from the server side. And also this is an example I call the client side, I call the search, my client search. So I have like a two example there. You know how I'm actually making that call and getting the result back. Okay, so that's how the client server are talk to each other. However, I did make some changes and such that now we no longer call HW6 client. Let me just bring up the update assignment. So I did the update. Now instead of having the the client, I have a two program, which is HW6 update, HW6 search. This one is derived from HW6 client. So what I did is that I have a two program. One program is just doing the update. One program is just doing the search. You can imagine that if you take the code I just showed you, it's essentially copy the code into two different code. and one is just handling the update issue, one is just handling the search issue. It's easier for you to do the testing. So that's why we have that. Okay.
So
Is that answer?
are
Go
those
ahead.
sorry, are those two new .cpp files? The
Yes.
homework 6 update and search?
Yes. What I have is two new .cpp file, which means that you
So,
need to change a little bit the make file and the other. Yeah, go ahead.
okay. So we would move the functions for update and search in homework 6 server over to that CPP file?
No, you don't touch the server. The
Oh,
server is still the same. So I have a three program, HW6 server, HW6 update. So when I do the split, I'm not changing anything on the server side. The server side remain the same, but it's HW6 client. Now we actually have two programs. So you change the client, you don't change the server. The server is still the same. The concept is the same.
so update and search.cpp files, they're both basically client files, but each calling update and search methods in homework 6 server?
Yes.
Okay.
Yeah. So if you look at the reason, the real reason, let me just show you why I did this change. Is kind of for this reason. Let me just do a one. You see, this is my original HW6 client, and you see that here I'm calling search, and here I'm calling update, right? I have a one part which is doing update, one part doing search. So I kind of have this two together. So when I test the program, because I need to do this multiple times, it's kind of hard for me to just changing the source code and do certain things. So that's why I decide, why don't we just split that into two programs? And so one executable file is just handling all the update, and the other one is just handling the search. That's why in the homework assignment that I actually gave you the test cases where the server is still HW6 server, but the client, now you can see the clients I call HW6 search, or I call HW6 update. There's two files here. Yeah, this is the update version of ECS homework 6 specification.
So do we have to create separate CPP files for update and search?
Yes, I think you need to do that. You need to do that. Yeah.
Okay.
But they will be, both of them will be very similar to HW6 client. So you can just reusing HW6 client to do that.
Okay.
I mean, I will say probably 80% of the code of, well, I would say HW6 client is very similar to HW6 update. HW6 search is a little bit different because search you need to do a little bit more. For example, I listed here, when you do HW6, right? When you search, when you actually do the search, that you will create a local file in the search, which I didn't do that in the client program, but you need to save that to a file, which means that you just get a JSON file and you save it to that file name. Which I would suggest you to also take a look at if you haven't done that for lecture 14. Lecture 14, I explained that using a more a diagram to explain the client side and server side, what file need to be executed. So I would suggest you to take a look at this test case sequence about what, especially look at what's expected on the client side and the server side, and then compare the PowerPoint slide for lecture 14. And that will give you some idea. So maybe I will show you here so you can see what's going on. No, not 15. I want to go to 14. Click the wrong file. Okay, if you look at this sequence of code when you do the search, okay, I think I started from here. Okay, from here, I do the search. You can see that I'm actually going through list by list about how you're going to do the search and the O key, and also the search the keyword, and then you can get, when you get this result back, you're going to save it over here. That's the sequence I was talking about. Okay. Yeah, this part is better. Oh, this part's update. Yeah, the update is the same thing. You have a local copy over here.
I actually have a specific question about update. So when you use the find function, after you find the which value it is in the map, are you assigning the post pointer? Are you assigning a value to post pointer, or
Yes.
assigning a value to
I'm
F pointer?
I think I answered a similar question earlier today, so I'm going to show you what I want to explain the concept, and then I will go to I show you the segment code about how to do that. I just want to make sure that the concept is clear. Okay, so
Okay.
I'm going to insert a new slide. So this is really under HW6 server, and this is a particularly true for update. Okay, so the first thing we will check, the first step is obtain the ID of the JSON string, right? The JSON object you get, it must have ID. The ID is in the format of profile ID and with underscore, and then with the post ID. Okay, the whole thing is called ID. Just make sure I want to clarify this. So this part is the ID you will get. So first you check, and the second thing you will check is that check the post map. You check the post map, and whether the ID, whether there is a post pointer that's actually have this ID, right? That's what the map is doing using the key ID value. That if this is true, that if yes, then you're okay. You're going to do a merge. If not true, you're not ready to merge yet. And then the other thing you want to do is you want to check whether there is a file exists. Whether that file will be post, and then this will be whatever ID and .json and at the current directory. So that directory, how do you do that? Use fopen. Use the fopen. So usually is the fopen. The first one will be the file name, and the second is read. If you want to open for read only, then you do this. Okay, and you got a pointer, which is usually a file star pointer. And how do you know if the file is there? You actually see if f is equal to null or not. Okay, so that's thing. So if you can get a file pointer, if f is not null, then essentially you need to read in the file. Essentially, this part, you're just doing HW5 produce. You're just doing HW5 produce here, because HW5 produce is going to bring in an object from a file that you input, and then you convert that to a C++ object, and then the result will go to that post pointer, and then you're going to do a merge. Okay, So this is the whole sequence about what situation you need to do the merge step by step. Okay, let me actually just move it up because I have something I want to continue writing. Okay, so this part, let me actually make it a little bit wider. Okay, like this. Okay, so now if none of this works, then you know that, okay, now this is not a merge, but it's a new object, a new post that you need to do. Okay, so this time you're actually going to do what? You're going to do HW5 I should just say JSON to post. You're going to call JSON to post, and the parameter is going to be my v message. Okay, and then the return value is going to be post pointer after the JSON to post. So this will give you something you can return back to the client. But the other thing is now you need to save this file. You need to save this file, which is called post id.json to file, basically. Okay, so it's just want to make sure that this is the flow of things that the object need to do. Let me just make this part different color, not to confuse. Okay, so we basically have three cases. Case one is that the object is in the memory, then your number one. This is a case one. I would just call it case one. Okay, that's not from my class. That's from my case one. And then this one is case two. By the way, here I will say this is case two, which means that the file is in the, let me make it bigger. It's not in the memory, but it's in the file. So let me change the color. I want to do this is a red, and this one is case two. Case two means that it's not in the memory, but it's in the file. So I need to bring it in. And then this one is case three. So there are three cases that we need to, your server program need to take care. So let me summarize what I just said. Three cases for server to do the update correctly. Case one, post in the memory, which means that you have a C++ post object you can find from the post map. Number two, post not in the memory, which means that you cannot find it from not found from post map. But there is a post something dot, okay, sorry, not this one, .json. There is such file on your file system. Okay, let me actually see if I can make this bigger. Okay, that's case two. And case three is that post neither in memory nor on file system. On the file system of the server side, of course. So those are the three cases I just talked about. Okay, so this is the three cases. Any question before I take a look at the code to deal with postmap? Any question?
Yeah, so for the last two cases, are you appending the map with an additional post pointer?
Yes, yes. When you create a post object, you always append the post to the post map. Yes.
Okay, and then when you save the file, do you use that with the post f pointer?
Hold on. We talk about the file. I'm talking about this file, right?
Yeah.
Okay. So let me tell you, when we talk about file, is that the file is there. So number one, we have to test whether that file exists. So therefore, we open this file and then we do this. Okay.
Yeah.
But this is the same as I do want to say that this is exactly the same what happened in HW5 produce. In HW5 produce, you offer the I think it's ARGV1 or ARGV2, which is the base JSON input, base input JSON. And that is the file you read it in, right? And that logic should exactly the same here when you're reading a file. So this part of the code is just reading a JSON file and then using the JSON to post, or your homework assignment number 5, you're just using that code to do that. The information flow and the procedure should be exactly the same. The concept should be exactly the same, okay?
Okay, I'm just confused where we would end up using post f pointer.
When we're going to use post pointer?
Post f pointer? Because in the program, it looks like you declare
I see. Okay,
a post
sure.
f pointer and a post
No,
pointer.
no, I probably that's the place. Let me take a look. What did I do? Use this must be on the. Let me do this. You're saying it's post f pointer, is that right? Yeah, I did that using this. You see that I'm using this as post f pointer. I read this the file name, so which means that this place you don't need to do that because I already done that. So it's a post f ptr. Post pointer, the data type is actually file star, which is a pointer to a file. When you open the file, if you open successfully, it's going to be something which is not null. If it's a null, then you know the open has failed.
Okay, I see. Thank you.
Yeah, you're welcome. So let me just check. Did I have that? Yeah, you see the definition is declare file star post f pointer, and then just open it and put it there. And then you see that this 3 line is exactly what I'm talking about, right? I check whether it's null or not, and for me to do that.
Yeah.
But you can see that also I did this. See, later I open the same file, I do W, write. So the difference between read and write, read is just read only, write is I write it back. Because once I got it, I do update, I merge, or this is a new object I never have. So I actually save it, I write it back to the file system. So then that essentially that object become persistent because you kill your program, as long as I have a file, I'm okay. So just want to tell you, this is conceptually is important for you to understand why we're doing that. So this case is really means that you do have a persistent object being available to you. Okay. All right. So if everybody is okay with this, I'm going to show you the code about postmap. Is everybody okay?
Yeah.
Okay.
Could I just take a screenshot of your previous slide?
Sure. I mean, I will. By the way, I will upload this slide to the server as well. You can take a screenshot now, and but I will this slide, right?
Yeah. Thank you.
Sure. Okay. So now I'm actually going to look at JUmp6 server. Okay, this is the place which is not redacted. So, but I think it's fair I'm share this with everybody. This is how I use the post map. Hold on. Okay, so you can see that here. This is corresponded. This one is actually checking for case 1. This check is actually check for whether case 1 is true. Okay, so here you can see, let me actually copy this code so I can parse this code a little bit better for you to understand what I'm doing. Okay, so essentially this is if, let me actually separate this into a few lines. Okay, I think that's better. So basically this if statement is saying that whether line number 2 is equal to line number 4, right? This is if statement. So, okay, I'm going to break this line even further to parse this one. So this part, I'm going to make an underline. Now, maybe I should do this. Okay, so you can see that what this line is my vMessage ID. Okay, this is getting the input in the find is basically say my vMessage ID, which is going to give you that long string looks like this. Let me show you. You're going to get something looks like this. No, I get it wrong. Sorry. Let me just copy and paste again. Okay, so this is the ID. So this is going to be the ID, and just say a string, I convert that into a string. So essentially what we're saying is postmap find is trying to find whether that ID is actually has a post pointer. So this I'm going to refer to the other slide, which I showed the other day. Just give me a second, let me pull it out. Yes, it's here. So this is basically ID is the string we're talking about. And then if you actually find the entry using that line, if it's equal, if it's equal to the post map n, that imply that basically you couldn't find anything in this map. Okay, that is the syntax for using map to clear that out. Need to go back here. Back there. Okay, so basically, if this one is going to return a index about which element of the element that has the key that we just provide, that you return that index. If that index is equal to n, then which means that you don't have that element in your system, in your memory. Therefore, if it is not equal, means that that element is definitely in there. Okay, so that's the check for whether you're case 1. So if it's not equal, you know you're actually under case 1. Okay, but now I'm going to go back to see, well, if case 1, what do you do? The case 1, if case 1, what you're going to do is I do this one. Okay, you can see my code. I'm not going to copy. I set the return code. I always do that. And then I just get using postmap and using the same thing, but not using find. Okay, I'm using postmap using the bracket, the key. So essentially is postmap bracket, the key value as a string. And then that is going to give me the second element that in the postmap, which is giving me, that's going to give me this element here. Okay, let me actually just color it so you know what that's going to give me. This one is giving this one. And then if I go back to code, and then it's going to return, because it's a pointer, I know that I just assign that to post pointer. So now I have a pointer for me to work with. So now I know it's a merge. What did I do? I just called JSON post merging, which is my V message. I just got it from outside. And the post pointer is the C++ object I already have in my memory. So then this is the perfect time for me to just call JSON post merging to merge these two together. So after the merge, by the way, the new result, everything will be stored in post PTR. So that's why at the end of the code, let me just flip through very quickly to the end. Very to the end, you see what I return is just return that post PTR dump J. Because it's already merged, I just return that, it will return to the sender. Okay? Is that good? Any question?
So I think that makes sense.
Oh, go ahead.
Okay. I had a question. What is the RC like?
It's a return code. RC is a return code. So RC is just defined as it's abbreviation for return code that we use in C programming or any programming a lot. So inside the implementation of this JSON post merging, there are some situations such as you missing certain element or certain type of my V message is not conform to the JSON post. So I'm going to provide some kind of signal saying that this process failed. And therefore, because it's failed, it will return a negative value. So the RC is going to be negative. So if everything goes well, the RC should be 0. The RC should be 0. But if it's being something goes wrong, then it should be some negative value. So later on, I can check when I decide to reply. I can check whether RC is equal to 0 or not. If it's negative value, then I'm going to return status fail, saying that your update is failed for one reason or the other. Okay.
And
yeah, go ahead.
The JSON comment method, I noticed that RC gets returned as 0, I think.
Mm-hmm.
But if it's returned as 0, even if it doesn't work, wouldn't that still return? Or maybe I'm remembering wrong.
You talk about hold on one second. If you talk about the comment at the end, it says return 0, right?
Yeah.
But in here, if anything goes wrong, I'm going to return immediately. So the code I redacted is I'm not I only, it looks like I only returned 0, right? I didn't return anything. But let me actually check, okay? Maybe you're right. I didn't actually return anything. Grep. parse return grab return.
In the JSON to post method, I'm pretty sure, I think it says it calls in RC is equal to JSON post common.
Yeah. I think I actually return -1 or -2 at certain places as well.
Okay.
Okay, I do have other places I return, but maybe or maybe not in JSON common. It may be in somewhere else. Maybe in the JSON to post, I actually return a minus value. Okay, so that's what RC is doing. RC is helping us to convey that there's something wrong with is mostly related to the myv message. Is, for example, you submit a JSON post JSON object, which is not really a post. Okay.
Okay. So in some of the if statements, or like throughout the JSON post common function, you just return as -1 as necessary.
Yeah, you can return -1 or return -3. I mean, for me, it's a negative value is good enough for me to just stop doing something. But if you want to convey some extra information about why you stop, then you probably need to use -1, -5, like my the small program or whatever. I actually return -13. From -1 to -13, they mean different thing.
Okay. So would a good place to return a negative number be if the ID is null? Because I noticed that on your terminal.
Right. If you have a JSON which is ID is null, that means I cannot handle, right? I mean, you're giving me a post. Every post must have an ID. If you don't even have an ID field, then that's actually going to be definitely a bad things for me to try to process. So immediately I return a negative value.
Okay.
So that RC will be negative, and then you will say status fail at that time. Okay.
Okay, makes sense. Thank you.
You're welcome. Okay, what I think others want to ask question earlier.
Yeah. Go ahead, Manuel. I think you raised your hand first.
All right, thanks. So for Homer 6 server CBP, for the search function, we could use a similar like method with the map, but then earlier you mentioned we could also use like a more convenient method with Oki.
Mm-hmm. I mean, Oki is also a map, actually.
Okay. I don't know. I haven't been working with Oki as much, so I'm still like a little bit confused on Oki. Maybe
okay, I can tell you about Oki. I actually give one slide to talk about what Oki is. Okay, let me actually. Do I have that Oki here? Okay, I will use what is Oki. Let me draw another slide to explain this concept, maybe graphically. Maybe it's better to do it this way. So this is try to explain the Okis and also what's Oki is doing. Okay, so first let's say what is Oki. So number one, I want to create something. I call it, this is what I call a vector of post pointer. Okay, vector or post pointer. I want to first say that this is, I want to explain what it is, and later you will see all these things is going to tie together. Okay, so what is a vector or post pointer? It basically give me a set of posts. So inside here, each of them, let me just pick up a pointer. You just have this vector has a bunch of pointer. Okay, and each of the pointer, of course, they pointing to some object, which is a post. So my post. So I'm going to have, assuming this post is here, and this post is here, and this post is somewhere in the memory here. Okay, so what I'm saying that this pointer is basically pointing to, each of the pointer is actually pointing to one of the object, right? So that's but the important thing is that this pointer is being included in this vector. So first I will have a concept called vector of post pointer, which is post pointer usually represent as a post star. Okay. All right. So that's the first concept. All right. So now with that, I can start talking about what is OKey. So OKey is essentially has the other part, which is the key. Do I have something I can use as a key? Let me just use something. Okay, I will just pick up this one as a key. Okay, I call this as a key. And this key, I will just call it ECF36B. Key is a string, just like you know, is a string. Okay, so here I have two things. One is a key, which is a string, and the other one is a vector or a pointer. And this two together is called OKey. I think I call it object key or something, but it's fine. It's this two together is a key. Change the color. Let me change the color of, no, this is fine. It should be fine. Yeah, I hope you can understand. It's not pretty. Okay. All right. So this is basically OKey. All right. Any questions so far? I just want to tell you what OKey is from the data structure perspective. Okay.
Are we using OKey in the search or update or both?
Only in search.
Okay.
OKey is used only in search. Yeah.
Thank you.
Okay. You're welcome. So I'm going to copy this part. So once you understand what is OKey, then I'm going to do something more interesting. So now I put multiple of such things together. Multiple. Here I only gave you 3, right? And okay, put it down. I don't want you to be here. Okay, but the thing is that the keyword is going to be different. Second one is Oracle. The third one is Patrick. Okay, so each of them represent a different key value. Okay, I have 3 of them, but this one I have 4. This one maybe I only have 2. And this one I have 3. Okay, so what does this mean? In fact, what I describe here, this is a map. This is called all-key map. This one is all-key map. And why this is all-key map? Because what I did is I put all the posts, the pointer to all the posts that have this key, ECF36B, I put it here. And all the posts with the keyword, key phrase Oracle, I'm going to put it here. And all the posts with Patrick, I'm going to put it here. So essentially, I organize a data structure that linking all the posts sharing the same key in the same place. So this is actually very convenient for me to do the search, because whenever you search, you provide a keyword. So what I did is I just using the map, STD map, to using that keyword to match whether that keyword belong to one of the entry. Okay, one of the entry, I'm looking at index into this map. And if I found out that, okay, the key you enter is ECF36B, then what I need to return, because I already gather all the posts that has the keyword here, then it's very easy for me to just return the whole thing back to them. So that's why I'm using the O key for me to do the search. So the search is really using this data structure, map the keyword and find the vector or post pointer, and then just extract each of the then. So now I have a 4-pointer. Guess what I'm going to do? I'm going to look at each of the pointer, take it out, do a dump J, create a JSON value representation of the post. And then you get the second one, you get the third one, get the fourth one, put this 4 JSON into an array, which is also a JSON, and then send it back to the client. And the client will see all the posts that's actually matching that keyword. So that's what search is doing using the O key. Is that
So
yeah,
is
go ahead,
the
Chi or the Melissa.
I'm confused because in HW6 server, there's no place creating this all keys map. I wonder where we have to do this.
Okay. Good question. I'm going to explain to you. So what I did is I actually hide it inside the JSON post redacted. So if you look at this is a JSON post redacted, that the first thing I have here is have all key. You see that? I have a map, which is O key, which is the first one is the key value. The second one is a pointer to O key, right? O key is the data structure for me to get the vector of everything. And this is called O key here. And then I provide 2 functions, which is I didn't redact this part, is for you to say get post by key. So you provide a key, I'm actually going to give you all the posts. So you just use get post by key, you can do that. And the other one is just get O key. You can provide a key, I will give you that value. So it's basically 2 functions, they're very similar to each other. Okay, so that's how you can use this O key. But the other thing which is also important is that, well, where do you insert? Where do you actually start building this? When do you start to building this keyword? How do you actually start building this part that you actually insert to fill up the content with this all keys map? And that's also in JSON posts. So I'm going to show you where that is. I thought I might still include it. Let me actually check, okay? Yeah, it's this part, but I actually, I redacted, but now I'm going to show you this part because I think the other session I did show this part of the code. So I'm going to unshare the screen first. Give me a second. Let me actually just make sure I don't unintentionally show too much. Okay, now I'm going to show this part. I'm 100% sure I actually shared this before, so I would just put it here. So this part of the code is under the JSON post comment. Okay, so inside the JSON post comment, I need to, when I process, the first time when I process an object from the JSON format, I'm actually checking whether whether the key value. This is a standard way of processing all segment of the data. okay? But this part is new to you because in Homework 5, you didn't have to deal with key. But if you see the structure of the code is exactly the same, you process reaction or links or action, they're the same. So, okay, this part is exactly the same, but the only difference is here. This part is the new thing. So what I did is that, okay, I use get O key. If you give me a key that you just want to enter, for example, this key LJV as string could be double quote ECS36B. So the first things I did is I actually extract that O key pointer associated with that key. By the way, I should tell you this. There is a two possibility if you look at the code. So the first thing I check is whether that key ever exists or not. The first thing in the O key, but here you see I'm calling this get O key. So number one, the key might not exist. So this is the test for me to see if that key exists. If the key exists, I would just return the key. But if the key doesn't exist, I just create a new one. I say, okay, key, O key, and then I assign I create also the post pointer, and I assign the key to the new key you just provide. Okay, so this is basically help me to the get O key is help me to process for this purpose. So now when you get the O key pointer, you know that you're getting the pointer to one of this data structure. In fact, it's pointing to here, right? Pointing to here. And then what you did is that you just push the post pointer because it has a vector. O key has a vector called posts. So you just push that my post pointer that you just created and push that in there. So essentially this slide I just highlighted is pushing that pointer in here. Okay, so
yeah,
this
that makes sense.
Okay, yeah, so that's two parts of the code. One is pushing in, one is get it out. Okay. All right. Melissa, you have a question? You
So,
raise your hand there.
oh yeah, so the use of O key isn't necessary, right?
Say it again.
The use of O key isn't necessary, right? If you just want to, like on the server side, you just want to go through every single key value pair in each JSON.
If you want to do that, that's fine. So this is just a reference implementation. I feel it's just to save me some time, so that's why I do it this way. But you can do it other way as well.
Okay, thank you.
You're welcome. Okay, any other question from the? Let me check. Do I have anything from the chat? Okay, here I have a chat. Jerry. Jerry, the reason you have that is I look at your map, your compiling line, you didn't include JSON underscore post.cpp or JSON underscore post.o. For some reason for that line, you're missing JSON underscore post.o. That's why it couldn't find JSON to post, because JSON to post, the function is included in the JSON underscore post.cpp. So that's why you need to include that. Maybe there's some messed up with the make file. Okay.
Professor, I think I've included.
But if you look at this line.
Yeah, I just sent it again to the chat. Post.o is right after person.o.
Oh, I see. Okay. No, where is that? The line you sent me, you have a post.o, but not JSON underscore post.o.
Oh, okay.
So let me quickly show you the file looks like. I think this may be, I forgot the reference implementation, whether I already have a JSON underscore post.o. Okay, maybe I have, maybe I don't. But I just want to show you, if you look at the make file, that inside my HW6, under my HW6 test history update, you look at this to update, I always have JSON post.o here. That's
okay,
that's the function I include. That's why you actually got that error, because you couldn't find it. Okay.
Okay, thank you.
You're welcome. Let me take a look at other thing. So for related to E, when you do HW6 search and search clause, you get no post ID, which means that if the post is not there, you should get a search fail. You should check the client side and server side. So the nice thing about client side and server side, you can add the cout statement on both sides to see if the result matching each other. Okay, so if you don't have ID, then you should actually see that also on the server side and client side. So similarly, to do the HW6 update, if you get an output on the client side but nothing on the server side, it might be okay, because you're just doing an update, right? The server side is not supposed to do anything, and you get that JSON back. But as I mentioned, that when you do the update, you should always update the JSON file, which means that now I bring back my slides again. So I was talking about when you do the update, okay? When you do the update, you should actually, after you do the merge or whatever, it's a new object or update, you should actually update this file on the server side. And that will allow you to actually see whether before you and after you run the program, whether the file has been updated, usually means that the file become a little bit bigger because you're adding new element into that. Okay, that will help you to check whether the result is correct or not. Okay, that's for E's question. Yeah, the thing is that, Melissa, you said the screen is blurry. It could be the networking issue, but don't worry, because I'm recording everything local. So after the session, I'm going to upload, so you should be able to see the clear one. Okay.
Okay, thank you. I also had a question about the .o files you just uploaded.
Right.
I saw that they're only for CSIF and OSX. Does that mean that if I have a Windows, I don't need to?
No, I haven't got a chance to do that. I will do that tonight. I will do that.
Okay.
I just need to go to the other machine to bring my the WSL and then just do the same thing. I will provide that as soon as possible. Yes, I know I missed that one. Yeah.
What's exactly the functionality of the .o file?
Okay, so the .o file is actually for you to track. I mean, for example, the .o file, the .o file inside here, that you see that in order for you to compile HW7 search, right? And it need to integrate with JSON post.o. So the thing is that you're not sure whether you have a right version of JSON post. Means that you're developing, your code has bug, and you try to isolate. And maybe before you can have a perfect implementation for testing, you can actually shuffle that .o file I provide here, assuming the same platform, and try to link the object and try to test the update and search and see if how that will work. I mean, one thing to see if your program work correctly is seeing that using your own version of JSON post.o or using my version of JSON post.o, whether they behave the same. If they behave differently, then you know there's something wrong, and there might be inside your JSON post.o or my JSON post.cpp has problem. That's one thing. But the other thing, which is also interesting, is that assuming you got a segmentation fault, and you want to know whether it's belong to JSON post.cpp or it's belong to HW6 server.cpp. So one thing you can check is you can shuffle the JSON post.o with my to see if you still get the segmentation fault. If you don't get the segmentation fault, then you know that segmentation fault actually happened somewhere in your own JSON post.cpp. So it's actually help you to do the testing. Because some of you are request that if I can share the source code from homework 5 and things like that. I feel that it's not because you want to continue to do development, but I feel that has a lot of issue with sharing the source code of homework 5, because that will create some other issue which I want to avoid. Okay, so that's the reason we use that. I gave you that file for you to do testing. But I'll be happy if you see that your program and replace that DAO file has some problem. I'll help you to look at your code. But I want you to develop your code, everything yourself. That's the purpose I try to maintain. Is that okay?
When you say shuffle, does that mean I just need to copy the file into my directory and then include it in the make file?
Okay, it might be a little bit. It might be more complicated than that. But I will tell you that you're right. But you need to do one thing before you can make the make, because the make file will actually check the timestamp of your .cpp file and the .o file. If they realize that, so let me actually show you this. So if I do a ls JSON post.star, you see in my directory I have a 2 file, right? My CPP is actually, the timestamp is actually new. Oh, wait a minute, where's my .o? I even don't have a .o. Hold on. Let me just compile it. Okay, you can see that now my .o file is actually newer than my .cpp file. So the make file is going to look at the timestamp and decide, okay, this is the time I'm not going to recompile JSON post.cpp. And so it will not try to regenerate the JSON post. So essentially what I'm saying here is you have to somehow trick make file not to override the JSON post.o you just downloaded from the cluster. I mean, even if it's override, don't worry, just re-download it again. That's okay. But one way to trick the make file is this. I mean, in this case, you can see if you type a make, it won't do anything. It won't actually. If I say this, I remove HW6 server. Okay, I remove this. If I say make, you can see that it's not recompiling the JSON post. It actually directly link all the .o file together because it checked, it realized the timestamp is actually pretty good. But here is a command I want to share with you. It's called touch. Touch is basically changing the timestamp. So if I touch JSON post.cpp, if I use this command touch, and then if I do ls this, now you see that the timestamp of JSON post CPP is actually newer than JSON post.o. So now if I actually type a make, it will recompile that, and then it basically generates the rest. Okay, So in order to avoid that, because you don't want the JSON post, if you want to use the .o file I provide, you don't want to do that line. So what you can do is that this is the way I usually do it. If I want to test a .o file, I just touch this one. Whenever I touch JSON post.o, I'm actually going to update the timestamp, so it will not trigger the regeneration of JSON post.o. Okay, does that make sense?
Yeah, thank you.
Okay.
I have a question, Professor, regarding homework 6.
Sure, go ahead.
I'm kind of confused on what we're supposed to put in for the history section for JSON post.cpp.
No, history, you just neglect that. Yeah, don't worry about that. That's for homework 7. So in some sense, history is very similar to, say, another vector of some object. It's a history object. I can just show you very briefly because I'm going to announce this very soon, probably today, what the history looks like. Okay, I just want to show you what history looks like. Do I have history? No, actually, history is a transaction. Okay, I know. So you can see that now I have a history, and the history is a transaction. Okay, so history is a transaction. It's also a vector. It's a vector of transaction, just like the rest of the vector. It's called history. And if you come to the transaction.h, it basically contains a bunch of things that related to this. Okay, and we're going to use that for homework assignment number 7. Just let you know that, and also have a dump.j and stuff. So, but you don't need to worry about that for homework 6. But you'll receive that information very soon. For homework 6, you don't need to worry about history.
Okay, thank you.
You're welcome.
I also noticed that on history, it has like the 3 dots. Does that matter if we leave it there, or should we delete those 3 dots?
Yeah, you can remove that 3 dots. Yeah, you can. You don't need to worry about that. You can remove that 3 dots. Yeah.
Okay, thank you.
Okay, I want to ask the question. Melissa, you said you have a follow-up question on Oki?
Oh, no, that was from before.
Okay.
I think the next question is from Jenny at 3:09 p.m.
Okay. Did you run the server, Jenny, when you tried to run that? That appeared to me is that the server is not running on the same host.
Yeah, I did. I opened a double terminal.
On the same machine, right?
Yeah.
And you have that issue. Okay. Okay. I mean, by the way, the implementation between the client server should be identical to homework 3. So let's do this because I don't want you to share your screen here, and maybe you can talk to me after this class at the private Zoom meeting. I can take a look. Okay.
Okay, perfect.
Okay.
Thank you.
Or you can just send me your HW6 server, HW6 client. I can quickly take a look and see if I can visually see there is a 1 typo or something like that. Okay.
Okay.
Julie, I'm actually answering your question. What is this function for in JSON? Which function you're talking about, Julia? Okay, so I guess it's not a function. You're talking about a piece of code. I'm calling this in array. So I want to just use the same example I gave the other day, which is should have a similar. I use that repeatedly in many different places. Okay, I'm going to go to my slide 15. So I talk about this in 15 about, so lecture 15, in fact, explain a lot about what is a JSON post CPP. For example, this is a whole everything about, is this 15 or 14? No, this is 14. Let me get rid of this. Save. Okay, so lecture 15 really cover what JSON CPP is and deal with some of the memory issue. Okay, so this is the function JSON post merging, JSON to post, and also JSON post comment. And the block of code you show is probably under JSON post comment. And inside JSON post comment, let me actually show you this piece of code here. It should looks like somewhere, let me see if this is the right example. No, it doesn't have that example. Let me grab it, just see where I have from the scenario. My v dot is array. Okay, I will do that. Okay, it's in JSON post, and let me just go through that from the beginning. Okay, so this, oh, okay, now I know what you're looking at. Okay, so this part of the code, okay, I'm just actually checking whether you're providing the right JSON format. So by the way, in JSON, that you could have one of these two cases. Let me use a different slide to describe that. So you could have a JSON which is starting with like a curly bracket, and then you start to have a key and the value pair. Okay, this is a one type of JSON. But the other type of JSON, it looks like this, is a like an array format. It started with a bracket, and then it has essentially the same thing for like this. Okay, so a valid syntactically JSON, a syntactically valid JSON could be either this one or this one. Okay, and the thing is that when we call this function JSON to post, we're expecting a post JSON cannot be the array format, cannot be this format. So this is actually, if you have a JSON value, which is, I call it JV, what do we call that? My JV, my J or my V, whatever. Okay, so when you have a my V, which is a JSON value, it could actually be this way or this way. But as a post JSON, that I want the first one, I don't want the second one. That's why I want to test whether you're giving me the correct JSON. So if you call this function, my V dot is array, and if you have this kind of JSON, it's going to give you, why didn't it give me that? It's going to give me false. But this one is going to give me true. Okay, so that's the difference. That's why the code I show you, I'm just trying to test whether you gave me the right JSON or not. So that's why I say here is that this is the wrong one. I'm actually expecting this one, but if you're giving this one, then I'm going to return the null. It means that I fail to produce the right post that you want to create. So this is just one of the check for me to add there. And that's the purpose. Try to differentiate whether it's an array JSON or it's a regular JSON. Does that answer your question, Julia? Yes, that's certainly possible, Gavin. There is all the function called reader. So you have a read and write, and let me just tell you, there is a set of function. Let me just using this. It's called reader. If you call read directory, you can open the whole directory. You can actually read directory, and the read directory interface will allow you to iterate through every single element, every single file name and the pointer within the same directory. So that's possible. I didn't have time to let you do this part, but in the future, if you want to build your own project, that reader is a very, very useful tool for you to do that. It's a Unix command for you to do. It's a similar, Unix command has two parts. One is manage the file, but the other says managing the directory. So using opendir reader, it will help you to do that, okay? Yeah, I don't think you need to change that part of code. Yeah, it's probably just return null. And maybe you want to print a message just for yourself. But that one, to be honest with you, I actually add that line. It was because at some point I was developing the code, and there is a one student's code. It actually generate the bracket, the format, which actually crashed the server. The server has segmentation fault. So that's why I add that test there. Okay, is there any other question?
I have a question on JSON post again
Mm-hmm.
for homework 6.
Mm-hmm.
We don't have to do anything for keys, right? The keys section.
For JSON post, no, you have to do that because that will be important for the search. For the search, we have to do that. I actually, Nathaniel, did you join the session a bit late?
Today?
Yeah, today.
Only like a couple minutes late.
Okay, then you probably heard me. That's okay. I mean, you can go back to see the code. I actually showed this piece of code. Let me just show that again, okay?
Thank you.
No problem. Okay, you see this part? I actually
Oh,
show this part. And this part is the key part. And because I show at least twice in the class, so I think it's fair to show this piece of code. I mean, the most important thing is that how do you use this get O key and also to push the my post pointer into the key. So when you do the search. So looking at this piece of code is very useful if you look at this piece of code together. So in fact, this piece of code get O key, you can see that it was used by use here. Okay, it's used here. Okay, this function is used here, but the other function was using HW6 server. So this part is actually used by server. You gave me a key, you just return a vector or pointer or post. And that's what I showed earlier in another slide. To use the map, to use the all key map. The all key map, by the way, is defined here in the same file. So that's why this is the key component of my implementation for search. But as I earlier said, that you could do it differently, then you don't need a structure. Okay, but if you want to follow this, that piece key down here, you have to do that. Okay, this piece has to be there here.
Okay, thank you.
Okay, you're welcome.
I guess if nobody else has a question, wait, never mind. Jenny Wang has one.
Yeah, I'm looking at that. Step 3 for test case 1. Let me actually. This one is test case 1, right? Yeah, this test case 1. Okay, step 3. I'm here.
I was kind of confused on how to execute that. So do we write the line with the $sign at the beginning as one line in our terminal, or is that two separate calls in our terminal?
You mean step 3?
Yeah.
Step 3 is just your terminal just type one line, this line. So
Okay.
after you type this line, that assuming your server is already running, right?
Mhm.
Then the server side, you're going to see this file created. And the client side, you're going to see the return, right? It's basically return, but at this moment, I didn't ask you to save as a file. So only the client side only save the file when you do the search.
So after we call that line in the terminal, we should see a new file within our directory?
Yes, on the server side.
I'm still kind of confused.
No, you have two windows, right? One window is the client server, and then I actually say you need to create two directories. One is a client directory, one is server directory, and you change to that directory. You change to the directory to actually run the program.
Okay.
So you go to the, yeah?
Sorry. How would we get our program to generate a JSON file? Because in homework 5, when we called homework 5 produce, we have an input and then we have the arrow to make an output JSON, but how would we would we have to write some code to make the server generate the new JSON file?
Yes. I thought I already include that. Let me check the code, okay? Yeah, this one is inside the. I'm going to share my screen. I already have that in the redacted version of the server. So okay, this file is the is HW6 server redacted version, and let's just take a look at this. This one is the update, right? This one is update. And you can see the update in the beginning is just processing all the information. So this is, the case 1, case 2, case 3 we're talking about. And at the end, after the RC is -0, you see everything is okay, update merge, and now I said write it back, right? When I do write it back, I basically starting this piece of code. I'm actually open the file, open the same file, the JSON object file you have construct earlier, but this time I open it with write mode. With write means I'm going to write it back to the hard disk and just open as a read only. This is a write mode. And inside here, it's pretty similar how you read it. But this piece of code, if you follow, is just a piece of a few lines. If you can open it, open the file pointer successfully, you just do the dump J of the string and then just write it back to that file point to the buffer, and then you use fwrite command like this way. And you write it back to the file, and at the end you close that file. That's it. So this piece of code, I hope you not just copy it, but you also understand how that works, because read and write, they're kind of symmetric to each other. Is that okay?
Yeah, thank you.
You're welcome. So I'm looking at Gavin's question. Oh, Gavin's question, I think I took care of that. Julia, Jenny. Okay. All right. Nathaniel, you say you have another question?
Yeah, it was on JSON_data within Homework 6 server. Like, I don't know kind of like, are there any pointers on how to start it?
Wait a minute. You said this file, HW6 server redacted?
Yeah, it's where it says JSON_data. It's like a little more down.
Something to do with data? This one? Oh, okay,
Yeah.
okay. All right. Okay. Yeah, of course. I can tell you what it is. Let me just double check, make sure I'm okay. Let me unshare my screen, and then I will double check before I answer this question. Okay.
Okay.
Okay. That's what I thought. Okay, I'm actually going back to the slide I have earlier to explain from there. I think it's easier. Wait a minute. I'm going to do it here. Okay, so earlier we talked about, this is what we call OKey map. All right, I'm going to copy this slide. So under search, if I want to search for the key ECF36B, so when I go through the OKey map with that key, then I'm actually going to, I won't have this anymore. And what I really have is just this pieces here, right? That's what I have for my result. So if you think about what this is actually have a 4-pointer. And then how do I actually construct the 4-pointer into something looks like this? Is really the return. Let me talk about how do I actually return to the client when they try to do a search with 4 posts together. So what I really have is this, is a JSON looks like this. Count is equal to 4. And then I have data, and the data is going to be an array. And then inside the array, I'm going to have 4 elements. And then that's the end of the array, and that's the end of the JSON. So essentially, what I like to do, let me actually make this is more colorful, and this one I'm going to use a different color, yellow. This one I'm going to make a color sky blue. This one I'm going to make a color purple. Okay, so I have 4 different posts I need to return. So what I did is I'm going to encode it and such that this 4 posts will be shows here. The first one's yellow. The second, oh, I cannot see this, right? I'm sorry. The second one is sky blue. The third one is going to be, I just want to be colorful a little bit. And then I'm going to explain this. Wait a minute, why it didn't change? Did I change the color? Okay, this is fine. And the final one is a gray one. Okay, so what I want to do is I want to eventually generate this. This is the button is the output I'm going to send it back to the client. Okay, so how do I actually do that? So from the code I showed you earlier using OKey, I actually obtained this 4-pointer, right? So now I'm going to tell you what I'm going to do is that number 1, I am going to, for each of the pointer, I'm going to call the dumpj.
So are the 4 vectors like reaction, link, those vectors, or?
No, each of this is actually a pointer to post.
Oh, okay.
So each of this I'm storing, so under the post, you have a reaction action, but each of this is a post. That means you have 4 posts that match this keyword. That's what the OKey is trying to get these things. So for each of this is actually a post pointer. So I'm going to call dumpj. I'm going to call dumpj. But the thing is that the dumpj is going to give me the dumpj is going to produce the content for each of this element, right? But what you saw, that's called, I think it's called JSON data, right? So JSON data is actually let me tell you what it represents. It actually represent, I have to have this to represent this two bracket. So essentially, JSON data is a JSON array that put the result of this for dumpj and put it together. Okay, and then I actually use then I put this array into this count and data structure, and then I have the whole thing. So in order for you to return an array of posts, that's you need to do with this JSON format. Is that somewhat answer your question, or is still somewhere you're confused?
I'm kind of confused on why there's still 4. Like, I don't see how 4 of them are necessary.
You said this 4?
Yeah, the 4 per.
No, it doesn't have to be 4. I just want to clarify this 4, just saying the server has 4 posts or 4 post object that contain this keyword. If you look at this, some of the keyword only have a 2, some of the keyword has a 3, some of the keyword has 4. This 4 means 4 object, 4 post object. Because I don't know, I mean, anytime how many posts that has this keyword called ECF36B. I don't know. That's just in general, we don't know, right? It could have 1 million or have 3, we don't know. So that is basically, this is just a storage for me to keep tracking all the pointer to all the posts that I have that has this keyword involved.
Okay, that makes sense.
Okay,
So,
think about that. It could be tricky that to understand that. Yeah. So if you don't have any, by the way, if you have like in the test cases, let me show you. The test case number 1, I really don't have a 1 object with ECF36B, but test case number 2, I have a 2 object. So let's actually make it simpler. Let's use test case number 2. So test case number 2, I have a 2 posts. They both have ECF36B, then you have 2. Then over here, you only have 2 of them, and then you can get rid of this part. Like this, okay? And then you need a data structure to kind of put them together this way. Okay, so I mean, if you understand this conceptually, think about this is being recorded, but I just want to tell you that how it looks like in the code. Okay, the code, in fact, it looks like this play. You see that what I did? I just want to show you this part of the code. So assuming this PV pointer is go through every single pointer that I have, and then you can see that I'm just go to the I mean, you have 2, then this I is going to be 0 and 1, the 4 is 0, 1, 2, 4. And for each of the pointer, I'm going to do a dumpj. For each of the dumpj, after you dumpj, I'm actually going to JSON data I is equal to this. So I'm actually putting into that array. And then at the end of this, after I put everything into the JSON data array, I just say result JSON data is equal to data JSON, which means that I actually now I have already created this JSON JSON underscore data, and then I basically put that into this become the result JSON, right? Sorry, let me push back a little bit. I still want to. No.
What do the RC less than 0 and RC equals -1 represent or mean?
It basically say whether you have anything wrong before this point. If you have anything that's -0 before this, that means there's something wrong. I'm not going to continue to work on this. That's why if say my V keyword is not even there, then I'm not going to return anything. And if you try to do get post by key and then you got a pointer which is null, then I couldn't do anything. So if anything goes wrong, I use a negative value. So later when I return, I will check whether RC is equal to 0 or not, because it's better not to return any data if anything goes wrong. So that's what RC is called, return code. That's just a common practice for the abbreviation of variable called RC. Okay, so you can see that here is a JSON data, then there's a result JSON, there's a result JSON for count and data, and then basically you have a nice JSON, and then to do this part, right? To get this part done. And then you can, okay, by the way, here, this should be 2, not 4. And then you can actually send, sorry, the whole thing back to the client. In the client side, they can now read into all the post JSON they receive, then they can actually create their own local object. Does that give you a little bit more information about what's going on?
Gives a lot up. Thank you.
Okay, you're welcome. Yeah, I mean, I have to say that this project, not just this one, but starting from homework 3 is quite complicated. I mean, I talked to the other student. I mean, part of this challenge of this course is that, I mean, individual concept is not hard, but when you put these things together, the complexity is just getting pretty hard, because you simultaneously need to understand a few concepts separately, and you have to see how they are related to each other. Yeah, and just I'm very happy to help you to go through this experience, because a lot of, I mean, this is me as a instructor, is that you sometimes don't learn this complicated concept until you actually struggle how they put in together. I hope that, you know, don't hesitate to ask me any question. Okay.
I have a quick question.
Sure.
It goes back to what was asked earlier about test case number 1, step 3.
Mm-hmm.
We have like .. homework 6 update.
Mm-hmm.
That's okay. And then there's .. JSON, and then / base input, and then blah blah blah.
Mm-hmm.
Why is that why did that second argument have like just JSON in between the /?
You mean
step 3? Well, yeah, the thing that's underlined in red right there.
Right.
I've just been using base input. I just
it's fine. It's the line is just because I actually put my base JSON under that directory.
Oh,
but
okay.
for your case, whatever you put it, you can just have
yeah,
that. In my case, I put it there. I put all my test case JSON under a separate JSON directory, but that's not necessary for your case. Okay.
All right. Thanks.
Yeah. Okay. So all right, I'm going to stop and to upload the video for you and for the rest of the class. If you have any question, just let me know. Okay, over the weekend I'll be still checking here. Okay. And thank you very much. And good luck and have a good
Thank you.
weekend. You're very welcome, all of you. All right. Oh, wait a minute. Gavin, you asked a question. I haven't looked at it. Yes, Gavin, when you clear that out, everything in the memory is gone, but everything in the file will still be there. Okay, that's why it's a persistent object. So it means that when people search for this object or update this object, we will bring it back and put that into the alt key. Okay. All right. Thank you. Bye.